Very good morning. Today's topic is regression analysis. Today we are going to discuss about the topic that is regression analysis. So in our daily life also we are seeing we can observe what is regression. So regression analysis we use in statistics. This analysis is useful for makes it possible to predict another variable on the basis of one or more variables. The general meaning of regression means it is a measure of the relationship between the mean value of one variable and the other value, the corresponding values of the other variables. So that is the meaning we can say about. So this is a statistical technique that relates a dependent variable to one or more independent variable. Means in this analysis we follow two variables. One is dependent variable, another one is independent variable. So in this, by following those independent and dependent variables, we will relate those two variables, then we'll do this regression analysis in the statistics. Okay. So this regression analysis, it helps you predict the effects of the independent variable on the dependent one. So the real life examples we can see the salary of an employee, that is an dependent variable, and the independent variables are based on the salary. What are the predictions about that person? Maybe the salary we can estimate based on his educational level or according to his working time or else based on his age, the age of a person. So these three are the independent variables to dependent variable of a salary. So what influences a person's salary means these three independent variables: time, educational level and the age of a person. These independent variables are the predictions based on the dependent variable of salary. Means in this regression analysis we will check the relationship between the one independent and another dependent variable. And also we can say that the age and height can be described using this regression model only. We use linear regression. Age and height of the person means a person's height increase as age also increases. So there is a relationship, that is linear relationship. So in this regression analysis, it is useful to predict the effects of the independent variable on the dependent variable, as well as the financial forecasting. Also we can use like the house price estimates or the stock prices, also and sales and promotions forecasting. These are all we can do by following the regression analysis only. So these are the some of the real life examples. So what is regression? So regression is a analysis, one of the statistical technique we use to check the variables, and we will do the analysis based on the variables. Means this is one type of study measuring the relationship between associated variables. So in this, one variable is dependent and another variable is independent. So this is called a regression. So regression means one variable is dependent on another variable. Means it is a measure of the relationship between those associated variables. So this is called the regression. So in this statistical tool, we study the nature of the extent of functional relationship between two or more variables, and we can predict the unknown values of dependent variable also. We can estimate. Means in the previous example only we had seen the salary of an employee. So that is a dependent variable. Based on the salary of an employee, we can predict the more variables. That predicted variables we can say it as independent variables. So that is about regression. So this regression is useful for the analysis. and it is used to determine how one variable is affected by changes in another variable. And also, this regression analysis, it helps to identify the strength and direction of the relationship between dependent variable and independent variable. And in this regression analysis, the dependent variable is the variable that is being predicted, that is already predicted, and the independent variable is the variable that is being used to make the predictions. Okay, so based on the dependent variable, we can that is already predicted, and the independent variables are those are being used to make the predictions. And the main goal of this regression analysis is to find the best fit line that can predict the value of the dependent variable based on the values of the independent variable. So this is about the definition and the meaning of regression. As we discussed now this regression analysis definition, and this regression analysis is commonly used in various fields like in finance, economics, marketing, and social sciences. So we are using this analysis. It is used to estimate the relationship between variables, between the dependent and independent variables, and we can predict the future outcomes and identify the trends and patterns in data also. So this is very most valuable information in the statistics to analyze the two variables. So we are having different types of regression analysis techniques. The first one is linear regression, multiple regression, logistic and polynomial regression. These are the four types of regression in this video we are going to discuss. And this regression analysis is related to the correlation also. Means when we where we are going to learn about the regression, and we need to know about what is correlation also. So in our previous videos we had already discussed about correlation. Correlation means it is the measure, the degree and direction of relationship between the variables, between the two variables. But in the regression we are measuring the nature and extent of average relationship between two or more variables. So that is the difference between correlation and regression. Based on the correlation also, we can do the regression problems. So first of all, we should be clear in the regression correlation, then we can learn these regression problems thoroughly. So let us discuss the one of the example for this regression analysis. For example, we can take the salary of an employee. So what influence a person's salary? So based on his salary, we can predict some of the independent variables. So those are predictors like his educational level and his working hours and the age of a person. These are the some of the independent variables, and those are called the predictors for the dependent variable of salary. So these three variables has influence on the salary of the person. Means you can predict those independent variables based on the dependent variables. So in this regression analysis, we are measuring the influence of one or more variable on the other variable, and the prediction of a variable by one or more other variable. These 2 points are very important in the regression analysis. And we can see what are the areas needed in regression. The first one is measurement of the influence of one or more variables on the other variable. So the measurement of the influence of one or more variables on the other variable means what influence children's ability to concentrate. So in this we can measure based on the influence. What influences children's ability to concentrate? And also we can see some another example. Do parents' educational level and places of residence affect children's future educational attainment also? So this is the measurement of the influence of one or more variables. And the second point we need to remember, prediction of a variable by one or more other variables. So prediction in this analysis we need to point out the prediction. Example, how long does a patient stay in the hospital? So there is a prediction will follow based on his reason for staying hospital and his age and some other predictions we can estimate. So this is one type of variables based on one or more variables. And what product is a person most likely to buy from an online store? So this is also a prediction. So in order to increase the sales of his shop, he need this regression analysis by following the prediction. So one is measurement of the influence of one or more variable, another one is prediction of a variable. So these 2 points are very important in the regression analysis, whatever the type of regression it is. So we are having the first one is simple linear regression or linear regression. So the example what we had discussed, the salary. So the salary is a dependent variable, and to that salary any one prediction we will follow. That is the simple linear regression. For one for dependent variable of salary, the independent variable is any one prediction like his age or working hours or educational level. Any one we will consider in this simple linear regression. Multiple regression means with the dependent variable of salary, we can consider one or more independent variables, education, working hours, and his level of education, all will come into this. So that is a multiple regression. That is the difference between simple and multiple regression. So here in this example, we can see regression towards mediocrity in hereditary structure. So average height of the tall parent is greater than the average height of their offsprings. So this is a one type of analysis, height and the offspring's height also. And also average height of short parents is less than the average height of the offsprings. So here we are considering the average height for the tendency of the human race to regress or return to a normal height. So like this analysis also we can do in this regression analysis. So, and also we need to know about the difference between correlation and regression also. So correlation means in this the name only we know it determines the interconnection or a co-relationship between the variables. Regression, it explains how an independent variable is numerically associated with the dependent variable. So that is the difference. Here there is a co-relationship between the variable, and here independent variable is associated with the dependent variable. And in correlation, both the independent and dependent values have no difference. There is no difference in between the values in the correlation, and in regression, both dependent and independent variables are different. The main objective of this correlation is to find out a quantitative or numerical value expressing the association between the values. This regression purpose is to calculate the values of a random variable based on the values of a fixed variable. And this correlation stipulates the degree to which both variables can move together. But whereas in regression, it specifies the effect of the change in the unit in the known variable on the evaluated variable. And also this correlation helps to constitute the connection between the two variables, and it helps in estimating variables value based on another given value. So this is the difference between correlation and regression. So in the previous videos what we had discussed about correlation, the correlation formula, correlation, the symbol is R equal to covariance of x comma y by sigma x comma sigma y. So we need to find out the covariance of those two variables x comma y. So the covariance of x comma y, the formula is this: summation of x minus x bar into y minus y bar by n. N means the number of samples we have taken, number of variables. And the sigma x equal to square root of summation x minus x bar whole square by n. And the sigma y equal to summation y minus y bar whole square by n. So this is the standard deviation. So this is the symbol of standard deviation of x value, standard deviation of y value we need to find out and add those all values in the formula, and we can get the coefficient of correlation value through this. So this is the recap of correlation coefficient what we had discussed. Like this we can find out the correlation coefficient value of the two variables or two values. And based on the answers we can give the conclusion about what type of correlation it is. Is it a perfect correlation or a very high or moderate or low or no correlation? If we got the answer +1 means that is a positive correlation. If we receive -1 as an answer for that problem, there is a negative value of correlation. So like this we can do the correlation coefficient formula problem to get the answer what type of correlation it is. And now we see the regression analysis for the linear regression. So the regression line means the lines of best fit expressing mutual average relationship between two variables. Between the two variables, we are finding the mutual average relationship between them. So those variables we can consider as x comma y. So the regression line of y on x, we can say it as y equal to mx plus c, and x on y means x equal to my plus c. The two lines cut each other at the point of their average. Here you can see the regression lines on the degree of correlation, x values and y values, and the degree of correlation between x and y. And if there is no correlation means r equal to -1, and if there is a high degree of correlation means we can see with the mean values of x bar and y bar, and low degree of correlation means we can see here with the mean values. This is the low degree of correlation. So like that we can find the regression line in the correlation by using the formula. So the regression equation we can see here the two variables for x comma y equal to mx plus c, and for the x equal to my plus c. So here we can see the slope, that is f, and the intercept, whatever the value here it is, that is the intercept value of c. So like that for the independent variable and dependent variables, linear regression calculation we can do. So the regression equation is y minus y bar equal to correlation coefficient and the standard deviation of y by standard deviation of x within the brackets x minus x bar. So the r is a correlation coefficient value and x bar y bar are the mean values of xy and the standard deviation values of y and x. So the regression coefficient is r standard deviation of y by x, standard deviation of x. So this is the regression equation we can follow. So what are the regression lines? Here we can see in brief explanation for that. So the regression line of y on x means this line gives the probable value of y. So the value of y is a dependent and x is a independent. So the regression line of y on x, y minus y bar equal to p by x into x minus x bar, or we can represent it as y equal to a plus bx. and the regression line of x on y is a vice versa. So like that we can write the equations, and we can do the summations of the two variables also, and the regression equation of y on x. Like this we can do the calculation. Y equal to a plus bx will change to y minus y bar equal to byx into x minus x bar. So like this we can do the calculation, and let us see some of the examples for this regression equation. Find the two regression equation of x on y and y on x from the following data. Here we are having the data of x and y values. X values are 10, 12, 16, 11, 15, 14, 20 and 22, and y values are those correspondingly. So we need to present it in the box for to do the calculation also. So mention all x values and y values and take their summation values. All by adding all x values we can get the summation x value. By adding all y values we can get summation y values. And next we need x square and y square and xy values. Square the 10 into 10 and y values 15 into 15, like that do all calculation and do their summation sigma x square and summation y square, and multiply the both variables x into y and do that summation also. So now we got all summation values, summation x, y and summation x square, y square and summation xy. So n means the number of elements in the x series or y series. Total is 8. And now we need to add all values in the equation. So the regression equation is as follows. Sigma x equal to a plus by. So we need to add all values in that and do the calculation. And we'll get the answer b equal to 0.8256. And in the same way, we can do to other values also. Then we can get the regression equation of y on x equal to like this. Y equal to 3.095 plus 1.127x. The same way, we need to repeat the x on y also. So like this, we need to calculate x on y and y on x equation. So this is the calculation for the regression equation of x on y and y on x for the given data. And let us see another example. For example, according to the given data, the age and blood group of 10 sports persons. The data was given here, the name of the persons and their age and their blood pressure values are mentioned here. So for this data, we need to find the regression equation of y on x and x on y and find the correlation coefficient using the regression coefficients, and also estimate the blood pressure of a sports person whose age is 45. So for this, first of all, we need to find out all the values for the given x values and y values and the name of the persons also, A, B, C, D, all what they mention. We need to mention in the box and find out all summation values of x, y and x minus x bar and y minus y bar and x square, y square and xy. We need mean values also for to find out the correlation coefficient. So the mean values will get x bar equal to the formula for average sigma summation x by n, 500 by n numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So by 10. So we got the x bar and y bar values. And the regression coefficients can be computed as like this. dxy equal to sigma xy by x square and y square, and do the calculation for both coefficients and do the regression lines. regression coefficients and regression coefficients of y on x and x on y, and substitute all the values in the regression equation. X minus x bar equal to bxy into y minus y bar, and y on x equation line also. So we got the two regression equations, x and y. And the second question they asked correlation coefficient. So coefficient of correlation, using the correlation coefficient value r equal to square root of bxy into byx. So we got the answer as minus 0.12. So there is a negative correlation. So we can see the low degree of negative correlation between age and blood pressure of a sports person. And we need to estimate that blood pressure of a sports person whose age is 45 can be calculated using this equation, y minus y bar into byx into x minus x bar. So there is a 100.708. So the estimation of pleasure of a sports person whose age is 45, that is 101. So like this we can calculate the regression analysis equations and correlation coefficient values also. And also we can see another example of regression equation x on y and x from the following data. So there is a xy values, do the summation of x and y and x square and y square and the summation of x comma y, and do the calculation. N means the number of values given, and substitute all the values in the regression equation. So we will get the x values and y values, the regression equations of x on y and y on x by doing the calculation. In the same way, this example also, the capital employed and the sales volume. For this, we need to find out the two regression lines. So same manner, you need to calculate the sigma x and sigma y summation values, all summation values, and substitute all the summation values in the regression lines. X minus x bar equal to bxy into y minus y bar, and the regression line of y on x, y minus y bar into byx into x minus x bar. And also the regression coefficients of x on y also. Substitute all values in the formula. So we'll get the regression lines of x and y. So like this we can calculate regression analysis for the simple linear regression. As of now, we discussed about the regression analysis, what is the meaning of regression and why we use this regression analysis, and some of the examples for this regression analysis, and the difference between correlation and regression, where we'll use the correlation and where we use this regression analysis. That difference we had discussed, and correlation recap also done by following the correlation coefficient equation, how we calculate that, and the correlation values based on the answers, what is the result of that correlation. And next we have discussed about the kinds of regression analysis.